Hey everyone, welcome to Homeschool and welcome back to Mind Map series. We started mind maps for the quick revisions on all the science chapters. Already 3 chapters mind maps are completed. Links are provided in the description. Please go and check the links for a quick revision. And this is the 4th session, and here I am going to discuss about electricity chapter. Let us quickly revise the entire electricity chapter in a best way. And guys, please don't lose your hope and have an interest. Don't lose your patience. I always say the person who is consistent, the person who is constantly studying, without getting deviated to the other things, is the one who will get maximum success in their life. Okay, so whatever may be the situations outside, the decisions towards the examination is still pending, but then don't lose your hope. According to me, maybe one fine day you should definitely give your examination. So work towards your goal and be focused towards your studies. Don't lose your hope and interest. This is a small suggestion from my side, and let us start the chapter. Very important chapter, and problems can be asked on this chapter where you have to concentrate a lot. And one more information, many of you kept on asking me to do a revision on problems. Say problem oriented chapters are two. One is light chapter, the other one is electricity. And electricity chapters problems, all models, all important models that they can ask in the examinations have been covered in target 60 physics video. Okay, see, I have done target 60 videos, 4 I did. Target 60 of chemistry, target 60 of physics, and target 60 of biology, as well as diagrams part, right? So target 60 physics video, the links I will give in the description. So in that video I covered all models on electricity, so you can refer that video. Clear? I think if you can understand those models, one of the other questions from those models only will definitely come for the examination. And coming to the problems on light chapters. See, in the playlist of light chapter, the last video is on problems on refraction. Okay, that is on lenses. Say all models would be covered in that video, and I concentrated on exercise questions mainly. All exercise models have been covered in that video, so you can watch that video for light problems. Clear? Once again I repeat, for light problems, playlist on light chapter, last video. And for electricity problems, target 60 physics video. Clear? So these are the videos, if you can refer. This is more than enough for all models of problems for both electricity and light chapter. Clear? And now let me quickly revise our electricity chapter in the form of a flow chart, which we call it as mind map, right? So our target chapter for today's class is electricity, and it's a quite easiest chapter also. Most of you feel this chapter difficult, but nothing is there in a chapter. Only thing is you have to understand everything properly. That's it, right? So this is our electricity. See, first and foremost, in a chapter, we will study a concept called electric current. So the first concept of the chapter is electric current. Okay, so you must know what do you mean by electric current. So definition of electric current. How do you define electric current? Rate of flow of charges, right? So what are the two things you have to concentrate from this topic? One is definition, right? Along with the units, and the other one is formula, and numericals can be asked based on the formula. So how do you define electric current? It is rate of flow of charges. And what is the unit of electric current? Unit is ampere, right? So which is denoted as A. So ampere, try to remember its unit. And what is the formula here? Formula is electric current I is equal to charge divided by time. Okay, so this is the formula of electric current. I is equal to Q divided by time. Q is nothing but charge. Okay, unit of charge is coulomb and the unit of time is seconds. So they may give you charge time, they'll ask you current, or they may give you current and time, they'll ask you the charge, or they may give you I value, Q value, they'll ask you T. Okay, so among the three, two variables they'll give you, the third one they'll ask you, and you have to concentrate the units here. Charge must always be there in coulombs, and time must always be there in seconds, and current must always be there in amperes. Okay, say you have to be focused with time factor, because in the question time will be given in hours and minutes, but you should convert that to seconds. Okay, if you don't convert time in seconds, you will end up in getting wrong answer. So you have to be careful with the units. All unit must be there in a standardized form. Clear? So that is all about electric current. Okay. And coming to the next topic of electricity, that is, potential difference. That is potential difference. I will write in a short form. Okay, because the space will not be enough because we need to complete so many things. But you don't write it as PD. What do you mean by PD? Potential difference. Okay. So what is important in PD? The same thing. Here definition is important as well as formula is important. Definition and formula. So what is potential difference? What is the definition of potential difference here? It is work done. Okay. Amount of work done for moving a unit charge from one point to another point. Okay, amount of work done for moving a charge, unit charge, or 1 coulomb of charge from one point to another point is called potential difference. Okay, so and again units are very important here. What is the unit of potential difference? It is volt. Okay, volts. So V, normally we represent the symbol as capital V, isn't it? Fine. And now coming to the formula, right? What is the formula you will give here? Potential difference is equal to work done divided by charge. So this is the formula for potential difference. Okay, so all formulas let me put up in a box. Okay, potential difference is equal to work done divided by charge. So work done is having a unit joule, charge unit is coulomb. Okay, so joule per coulomb is called as volt. Clear? So that is the unit of potential difference. Clear? So this is our second topic. And coming to the third topic. The third topic is very, very important. That is Ohm's law. Ohm's law. So here in the Ohm's law, you know what? Here also there are two things which are important. So one is definition, and the other one is formula. So how do you define Ohm's law? Ohm's law is nothing but the potential difference across a conductor is directly proportional to current carrying in a conductor provided temperature constant. Yes or no? Say I repeat the definition once again because I don't have a place to write the definition. So I am repeating it. Try to revise it. And potential difference across a conductor is directly proportional to current that is carried in a conductor keeping temperature constant. Okay, and what is the formula you will give here? Formula can be V is equal to IR, right? So based on a formula, definitely problems can be asked, and the formula is very, very important. V is equal to I into R. What is V? Voltage or potential difference. What is I? Current. What is R? R is called resistance here. What is this R? R is resistance. Okay, so this is all about Ohm's law. Clear? And now I am going for another important concept of the chapter, that is resistance. Resistance. Okay, resistance. In case of resistance, the very important topic is factors affecting resistance. Factors affecting resistance is very, very, very important. Clear? And what do you mean by resistance? Can you tell me what do you mean by resistance? It is nothing but obstruction to the flow of current. Resistance is nothing but obstruction for the flow of current, disturbance for the flow of current. Okay, so that resistance depends on various factors actually. So here the resistance actually depends on the length, right? So how is the resistance depends on the length? Always the resistance is directly proportional to L. L means length. Okay, as the length of a conductor increases, resistance also increases, right? And another factor is area, right? And how is resistance depending on area? Resistance is always inversely proportional to area. Okay, fine. And the third factor is temperature. Third factor is temperature, and our resistance is directly proportional to temperature. So here T means temperature, not time. Okay, so as the temperature increases, our resistance also increases. And next one is resistance also depends on nature of material. Nature of material. Clear? So factors affecting resistance is the most important topic. It can be asked for 2 marks or 1 mark. Resistance depends on length. It is directly proportional to length. Resistance depends on area. It is inversely proportional to area of a cross section of a conductor. And resistance is directly proportional to temperature. And resistance also depends on the nature of conductor or the nature of material. Okay, and we have a formula for resistance, that is R is equal to rho into L by A, right? So this is the formula on resistance. Another formula for problems. And what is this rho? Rho is a constant here, which we call it as resistivity, which is called as resistivity. Resistivity is nothing but it is a property of material. Property of material. Okay, so resistivity does not depend on length of a conductor, area of a conductor, doesn't depend on temperature, nothing. It is just the property of a material. Okay, say the same formula I can also rearrange and write rho is equal to RA by L. Okay, so both formulas are important for the problems. They may give you rho value, L value, A value, and they'll ask you to calculate resistance. And can you tell me what is the unit of resistance? Unit is ohm. Okay, and or they'll give you resistance, they'll give you area or diameter. Okay, or they will give you length, and they'll ask you to calculate resistivity. And resistivity unit is ohm meter. Okay, say both problems are very, very important, and actually this is one of the model of electricity problem. Okay, you have to concentrate the problems on these formulas. Fine. So that is all about your resistance and resistivity. And the next topic that I am going to discuss is, resistors in groups. Resistors. Let me write it here. Resistors. Resistors connected in groups. Resistors connected in groups. Resistors can always be connected in two ways. So one is series combination. Resistors can be connected in series and resistors can also be connected in parallel. Okay, say in case of series combination, this is the symbol of resistance. So if the resistors or instruments are connected this way, it is called as series combination, right? If they are connected in parallel, something like this, then it is called as parallel combination, right? So what happens in series? In case of series combination, I remains same. I is constant. I is constant through all the resistors, okay, and whereas voltage divides. Voltage is not constant, voltage divides. Actually voltage is different in different resistors. So whenever something is connected in series, I is constant, voltage is getting divided, whereas the things are opposite here. Okay, in case of parallel combination, I divides. I divides and voltage is constant. V is constant. This is what you have to remember, conceptual, very, very important. And one more thing is, if you want to calculate the total resistance when the resistors are connected in series, then the formula is Rs is equal to R1 plus R2 plus R3. This is the formula you will use. Again, this is very, very important formula. Clear? When you have to calculate the total resistance in series, the formula Rs is equal to R1 plus R2 plus R3. But if you want to calculate the total resistance when resistors are connected in parallel, then the formula used is 1 by Rp is equal to 1 by R1 plus 1 by R2, etc. And one more point that is important to remember is always parallel connection is advantageous over series connection. Okay, so whenever you are connecting certain instruments in a circuit, you have to connect them in parallel. It is because current is dividing here, voltage is constant. Different instruments need different current, different amount of current. So when you connect the things in a parallel combination, the instrument will stay in a safer condition and it will get whatever the current it wants, right? When you conduct the things in a series, for all the instrument the same amount of current would be passed, where you'll have more chance of getting damage. If one instrument is damaged, then the entire circuit will be broken, right? So that is why always parallel connection is more advantageous over series connection. This is a very famous question. It was asked in the model paper also. So what is the answer you will give? In parallel, the current divides. In series, the current remains same. Okay, so that is the main point, key point that you have to mention as an answer, right? So this is about resistors in groups. And now next topic that we are discussing is, Joule's law of heating. Okay, so next concept is Joule's law of heating. So they'll ask you the formula here. So, whenever you have a certain resistors are associated with certain level of heating, right? And that heat is always, depends on, or it is directly proportional to the square of current, right? And it is directly proportional to the resistance, and it is directly proportional to time t. Okay, so the heat content of a resistor is always directly proportional to square of current passing in a resistor. Okay, and it is directly proportional to the resistance of a particular conductor, and it is directly proportional to the time for which the current is flowing, right? So this is the formula that you have to remember for Joule's law of heating. Again, an important formula. And coming to the last topic of the chapter, that is power. See, problems on power is most frequently asked model on electricity. So you have to concentrate on power. Okay, so what do you mean by power? Let us discuss what actually the power is. It is nothing but rate at which electric energy is consumed. Electric energy is consumed, right? So this is what we mean by power, right? Power has so many formulas actually. Power is equal to V into T is one formula. Voltage into time is one formula, and you can also use power is equal to V square by R. In terms of resistance also you can write the formulas of power. This is second formula which is important. And the third formula, P is equal to I square R. This is your third formula. So there are three formulas for the power. So when voltage and time is given, this formula. When voltage and resistance is given, this formula. When current and resistance is given, this formula you have to use, right? And now the thing is, here one more important thing is, what is the unit of power, right? The unit of power is watt. The unit of power is watt. And one more thing, energy. We actually use electricity in the form of energy, right? And we will pay the money for electrical energy, right? So if you want to calculate how much electrical energy you have used for a particular instrument, then it is always calculated with the help of this formula, that is energy is equal to power into time. Okay, so energy, electrical energy is always is equal to power into time. Okay, and the unit of electrical energy is kilowatt hour. Okay, so electrical energy is always measured in the unit kilowatt hour, right? And problems on electrical energy and power is another important model you must compulsorily concentrate, right? So here problems can be asked on these formulas. First important formula is this, I is equal to Q by T. Here units have to be very, very careful. Time you must consider in seconds. They will give it in hours and minutes, but you should consider in seconds. Okay, you are calculating your answer in ampere, and Q, charge unit is coulomb. Fine. And next important formula is this, work done unit joule, charge unit coulomb. Okay, potential difference. So this is another important formula. And the next one would be your Ohm's law formula, V is equal to IR. After that, these two formulas, calculation of resistance, calculation of resistivity. So R is equal to rho. Rho is resistivity into L divided by A. Length they will give it in meters. It should be in meters. And area. Okay, most of the times they'll give you diameter. Okay, you take it in A. Clear? Fine. And similarly, you have to calculate the value for resistivity also. So both formulas are important here. And after that, series connection and parallel connection. Total resistance to calculate in series is this. Total resistance to calculate in parallel is this. This is also one of the important model. Every year they kept on asking from electricity chapter. Again, on this model, I solved the questions in the target 60 video. Please refer, you will get an idea how actually problems can be asked on this concept. Okay, and after that, Joule's law of heating definition they may ask you, or they may ask you the mathematical form. This is the mathematical form of Joule's law of heating. Okay, so what is I here? I is nothing but current. Okay, you must know the meaning of these terms. R means resistance. R means resistance and T means time. Okay, so explain the mathematical equation they'll ask you. You must know the meanings of these terms, and you must know how does heating effect depends on various factors. Okay, so heating effect depends on the current, resistance and time. How does the heating effect depends on current? It is the square of current. How does the heating effect depends on resistance? It is directly proportional to resistance, and it is directly proportional to time. Okay, fine. And after that, this is the most important topic, power. Problems can be asked on this. Three different formulas for power, and what do you mean by electric power, and what is electric energy, what is its formula, what is its unit, and what is the unit of power. Okay, so this much is the electricity chapter that you have to concentrate for board examination. Okay, so problems are very important. At least one problem is definitely asked for 3 marks. Okay, and also few definitions and few concept oriented questions also may come. Clear? So now take a screenshot of this particular mind map and do revise carefully. So done with the screenshot, isn't it? So the next chapter is periodic classification of elements. This is a much simple chapter. So meet you all in the next session. Do subscribe our channel and share the videos to a maximum friends so that everybody gets benefit. Thank you so much.